In this video, we're going to look at discrete random variables. So here we've got a random variable x, and it can take on the values of 1, 2, 3, 4, and 5. So we've got a discrete random variable x, and it can take on the values of 1, 2, 3, 4, or 5. The probability of all of these events has to add up to one whole, because the probability of all mutually exclusive events have to equal 1. So we can work out the value of k, the probability of getting a 4 or a 5, by seeing what's left here. So we've got 0.2, 0.1, and 0.1. Actually, we'll write it down. So 0.2 plus 0.1 plus 0.1 plus our 2k's have to add up to 1. So 0.4 plus our 2k's have to add up to 1. If we subtract 0.4 from both sides, our 2k's have to be 0.6, which means each k must be 0.3. Here we've got a question. It says find the probability that x is bigger than 2. So it can't equal 2, it's got to be bigger than 2. So that means it could be 3, 4, or 5. So we've got 0.1, 0.3, and 0.3, which gives us 0.7. So the probability that x is bigger than 2 is 0.7. Part C, find the probability that x is bigger than 2 but less than or equal to 4. That means it can't be 2, but it can be 3 or 4. So that's 0.1 plus 0.3, which is 0.4. Okay, so we've got a very similar question. If you want to pause the video, give this one a go, and then press play when you're ready to go through the answer. So we've got a different discrete random variable this time. This time we can have 0, 1, 2, and 3. And the probability of all of the events has to add up to one whole. So far we've got 0.3 plus 0.2 plus 0.4, which is 0.9. So k must be 0.1, because all the events have to add up to one whole. Find the probability that x is less than 2. So that means it can be 0 or 1, which is 0.3 plus 0.1, 0.4. Find the probability that x is bigger than 1.1. So what's bigger than 1.1? We can have 2 or 3. So 0.2 plus 0.4, that's 0.6. Okay, so a discrete random variable x has the following probability distribution. So for when x is 1 and 2, the probability is 0.1. For when x is 3 or 4, the probability is 0.2. And for when x is 5, the probability is k. So I'm going to do part B first. I'm going to draw the probability distribution. So we can have 1, 2, 3, 4, and 5. The probability of 1 and 2 is 0.1. The probability of 3 or 4, 3 and 4 even, is 0.2. And k is 5. So what do we have so far? We've got 0.2 plus 0.2 plus 0.2, We've got 0.6 so far. So k must be 0.4. Because all of the probabilities of the events have to add up to one whole. So there we have our probability distribution for x. Okay, here's a different question. If you want to pause the video and try and give it a go, you can. Otherwise, just keep watching. So this time, x can take the values of 1, 2, 3, 4, and 6. And for 1, 2, and 3, it has the probability of kx. So when x is 1, k times x is k. For when x is 2, k times x is 2k. For when x is 3, k times x is 3k. And for when x is 4, the probability is given by k times x minus 1. So for when x is 4, that's 4 minus 1 is 3, so that's 3k. And for when x is 6, x minus 1 is 5, so it's 5k. So we're going to find the value of k. So all of the probabilities have to add up to one whole. So k plus 2k plus 3k plus 3k plus 5k have to equal one whole. So we've got 3, 6, 9, 14 k's equal one whole. So k must be 1/14. So we can redraw our probability distribution. So k is 1/14. So k, the probability of 1 is 1k. That's 1/14. For 2, it's 2k, which is 2/14. Or we could write 1/7. For 3 is 3/14. For 4 is also 3/14. And for 6 is 5/14. Okay, this time we've been given our probability distribution, and we are being asked to draw the cumulative function. So the cumulative function, which is called capital F(x). So this time, all we've got to do is add up as we go. So f(x), a cumulative function. So everything up to 1, everything up to 2, everything up to and including 3, 4, 5. So everything up to and including 1, that's 0.15. And then for 2, we're going to add 1 and 2. So add the probabilities of 1 and 2. So 0.15 plus 0.25, that's 0.4. For 3, we're going to add the probabilities of 1, 2, and 3. So that's 0.5. For 4, we want the probabilities of 1, 2, 3, and 4. So that's 0.8. And by the time we get to 5, we've got all the probabilities added up. So we should have one whole. Write down f, so the cumulative for 2. Everything up to 2. Everything up to and including 2. So f of 2 is 0.4. Write down f 3.1. So everything up to and including 3.1. So that's 0.5. So everything up to and including 3.1 means 1, 2, and 3. Okay, here's a different question. Pause the video, give this one a go, and press play when you're ready to go through. So we're going to have the cumulative function with a capital F and an X. And X can take the values of 1, 2, 3, 4, and 5. So everything up to and including 1 is 0.2. Everything up to and including 2, that's 1 and 2 together, so 0.6. Everything up to and including 3 is 0.7. Everything up to and including 4 is 0.8. And the last one should be 1 whole. Write down f of 2 or f2, everything up to and including 2. That's 0.6. And everything up to and including 3.1. So it's those ones, which is 0.7.